Hi everyone, this is my Lab 1 report. Here is a quick overview of what I'll talk about with an introduction, the experiment, the computational model, and the discussion and conclusion. So first, in the introduction, we have the purpose of the lab, which is to determine how the charges of objects can affect their interactions in motion, and observe and calculate the transfer of electrons from one object to another. Then we had some initial assumptions where we would ignore air resistance, assume each U-tape has the same charge, and treat a tape as if it were a point charge. So some of the fundamental physics principles utilized in this lab is Coulomb's law with the formula below, the electric force, gravitational force near Earth with the formula below, and Newton's second law. So a quick overview of the results is that we found both U-tapes are positively charged based on seeing their movement when put close to a hand, pen, coaster, and another U-tape. We also found the charge of the U-tape to be 1.37 e to the negative 8 coulombs, and there's an electron deficiency of 8.56 e to the 10th electrons. So moving into the experiment, we first have the methodology where first we would charge the U-tape. So create a base tape and rip off the U-tape from there and do that twice. Then we would check the U-tape charge with our hand, with a pen, and check with the neutral coaster just to determine it's correct. And lastly, calculate the charge of the U-tape. So we would put one U-tape above another and raise the second U-tape underneath the first until the first begins to float. And then we would record how far away they are from each other at this point. And so some of the initial conditions for the lab were the system is U-tape 1 and 2, the surroundings is the Earth, and then we also recorded the length, width, mass, and the distance between the U-tapes. So some experimental observations is that when we checked with the hand, pen, and coaster, the U-tape was attracted to all three of these, but it was repelled by U-tape 2. So moving into some of the other calculations is we found the magnitude of the gravitational force on the floating U-tape to be the 0.002. And we also know that the electric force is equal and opposite to this force, so it does have the same magnitude. And we also found the charge of the U-tape and utilized this to find the electron deficiency, which is just the charge of the U-tape over the charge of an electron. Then we found the number of atoms in floating U-tape, where you take the area of a tape over the area of the atom. And lastly, find the ratio of electrons to atoms on the floating U-tape. So moving into the computational model, we actually utilized a lot of the same information in GlowScript and first went into creating the constants where we have the electron charge, the tape's mass, length, width, g, as well as the distance between the tape. Next, we actually did the same calculations as we did in the experiment. So first we calculated the gravitational and electric forces on the tape, then calculated the charge of a piece of tape, then its electron deficiency, the number of atoms on one piece of tape, and the ratio of electrons to atoms on one piece of tape, and then we printed those results. And lastly, in order to visualize this experiment, we created some visualizations where we had tape 1 and 2 as point charges and also created arrows for the electric force and gravitational force direction and magnitudes. And now you can see that in the code output as well as the printed statements below. So moving into the discussion and conclusion, we see that both U-tapes have a net positive charge. And because of this, they each have an electron deficiency. And we also know that the system was in equilibrium, meaning that the gravitational and electric forces are equal and opposite in this case. So some possible sources of error is that touching the tape too much could have changed the charge to make my calculations less accurate. The length and width of the tape measurements could have been slightly off, and the possibility that the charge of each piece of tape might not be exactly the same. And so to answer the what if question, we see that the interaction between the U-tapes would still be the same if electrons had a positive charge and protons had a negative charge, but the direction of electric force and field would change, but we would have seen the U-tapes interact differently with the other charged objects, meaning that they would have repelled the hand, coaster, and the pen, as well as the other U-tape. And lastly, for the why question, we see that the charge of the U-tape is altered when in contact with another object because electrons are transferred during contact, and the positive charged tapes can have an electron deficit. Therefore, the longer an object is in contact with my hand, pen, coaster, or another U-tape, the more the charge of the U-tape can change. Thank you.